Hello. Now we're going to have a look at what we call the ambiguous case for the sine rule. Now, ambiguous just means in this particular situation, there are two possible answers. So let's have a look at a particular question. So we've got triangle ABC we're going to draw here. Now, it says angle A is 33 degrees. So let's put that information on here. But let's go, angle A is 33 degrees. And it says side A is 6 centimeters long. Now, side A has to be opposite angle A, because that's how these things work. So side A is opposite angle A. So here's side A, it's opposite angle A, and it has to be 6 centimeters long. Here it is there. Now, the other piece of information they had is that side B is 10 centimeters long. So if we put B there, then side B has to be opposite it, which is 10 centimeters over there. And then it says find the size of angle B. So that's this one here. Okay, that's what we need to find. Okay, so the question is though, when I drew my side A, which was opposite angle, when I had my side here, I could have put it that way, but I also could have put my 6 centimeters in this way. And if I did that, my angle B is no longer the same size. So this would be an obtuse angle. See that? It's bigger than 90 degrees. But if I put it over here, if I draw another one, change its color to match the one I had before. Oh, I'm not going to change its color. Anyway, I can see here that this angle would have been acute. So they're both 6 centimeters long, and they can both happen with that information. So let's have a look at an example. So here is the two possibilities. So we have side angle A, angle B, angle C. So that's side B, that's side A. Or we could have had angle A, angle B, that would be C, that's side B, and that's side A. In this case, that angle would be obtuse. In this case, that angle would be acute. And they're both possible with that information. So what are we going to use to do this? Let's get rid of this information. We are going to have a look at what we've been given. Given an angle and the side opposite it. And we've been given a side and we want to find this angle. That's the one we want to find. In the same way over there it works. That's also a pair. So what do we do when we've got two pairs like that? We will need to use the sine rule. So let's get the sine rule going. Now I want to find an angle. So I'm going to put the sine of the angle on top. So that helps me find the angle sine B on B. Now we've already got A's and B's, so we may as well just use them as they're written. So let's go sine of angle A, which is 33 degrees. And the length of side A that goes with it is 6. And sine of angle B, we don't know what it is. That's the one we want to find. That's the one we want to find there too. It goes with side length 10. Now, I want to get the side B, sine B by itself. So I need to multiply both sides by 10. As that goes down. So I've got sine of B is equal to whatever 10 times sine of 33 divided by 6 is. Put it into your calculator. I get 0.907731, etc. Keep that in your calculator. Now we are finding an angle. What do you need to do when you find an angle? You must do inverse, sine inverse, using your calculator, the shift or the second function button, whatever. Leave it in your calculator and just go sine inverse. And you get an answer of, let's go to the nearest whole degree, 65 degrees. Okay. Now, that's the acute angle answer. That's this one over here. And that's this angle there. That's the 65 degree one. But what about the obtuse angle? Okay, well, what you can do for the obtuse angle, you can go or B is equal to, and you go 180 minus 65. Okay, 180 minus 65 will give you 115 degrees. And that's the obtuse answer. So there we go. This has two answers, 65 degrees or 115 degrees. That's the ambiguous case.